By the end of this lesson, you will be able to optimize using what's called linear programming. Linear programming, it comes from the word linear meaning line, right? And so we will take linear inequalities, which we call constraints, find a feasible region, use the vertices of that feasible region to then substitute into a function to find maximum and minimum values. And I'll be honest, when I first started teaching this, I never really saw this used outside of what I taught. However, oh gosh, about 5 years ago, my husband took a course in logistics because he's a warehouseman, so he was getting a logistics certification, and so many of the problems that he had to do for his course use linear programming. So each of your inequalities are called what's called a constraint. And it says, all right, my possible solutions have to be bound by these constraints. And then I take those possible solutions and I put them into a function to find my maximum and minimum values, like maximum profit, minimum loss. So this is used a lot in business. So what we're going to do, so if you look at this example here, we're going to find what's called maximum, which is the highest value, and minimums, which is our lower values. So whenever a system produces a bounded in a polygonal region, meaning a bounded region that's a polygon, meaning all this, a polygon is just a shape. The maximum and minimum values of the related function will occur at the vertex. So what we're going to do first is we're going to graph our inequalities. So if you look at your example, these are the inequalities that are graphed in this graph over here. And we go to find the vertices. So here's the 4 vertices. So you have the point 0, 4, which is right here. 0, 4. Right here is the point 2, 4. Here's the point 5, 1. And then over here is -1, -2. All right, and then what you're giving a function, which is a function of x and y. So if you look, we've already talked about functions that look like this, but since we're going to substitute x and y, it looks like this. So a function of x and y. And so they give you something to substitute into. So if you look at this example right here, we take the first vertices, 0, 4. We substitute 0 in for x, 4 for y. 3 times 0 is 0, plus 2 times 4, which is 8. 0 plus 8 is 8. Then we do the same thing with 2, 4. So we substitute 2 for x, 4 for y. 3 times 2 is 6. 2 times 4 is 8. We add those together, we get 14. We do the same thing with 5, 1. Substitute that in, and we get 17. And finally, we substitute in -1, -2. And we find that that value is -7. So 8, 14, 17, and -7 are called values. So those are different values of the function. And we want the maximum value, which is our highest. So that's 17. So that might be your maximum profit, the maximum amount of, your maximum profit. And then like -7 would be minimum, like what's my minimum loss? What's the least amount of money I could lose in this? All right, so there's your minimum value. All right, so that's what we're going to do. We're going to graph some inequalities, find the vertices of the enclosed region, then find the minimum and maximum values that go with each. And again, this is used a lot in business, warehousing, logistics, and stuff like that. So here's example number 1. Again, I'm going to use Desmos as a tool here. So I have y is greater than -2. 1 is less than x, which is less than 5. So what this is saying here, this function here, is saying that x is between 1 and 5. And you can type it in Desmos just like that, and that's these 2 lines right here. So x is between the 1 and the 5. And then y is less than x plus 3, right? So that creates an enclosed region right here. And let me draw this in yellow so it's a little easier to see. So here's my enclosed region. And then again, I just clicked in Desmos to get my vertices. All right, let's transfer that graph to over here so we have it. So let's see, 1, 4. And then 1, 2. And then 5, 2. And then 5, 8. 1, 2, whoops, 5, 8. 3, 4, 5, 6, 7, 8. All right, and all these are going to be or equal to. All right, so these are all going to be solid lines. And again, I don't have a straight edge, so I'm going to try my best to draw. I recommend you using a straight edge. All right. And the enclosed region is right here. This is where all the graphs overlap, is in that area right there. So you got to be careful in Desmos. Sometimes it's hard to see. And if you click on this and hold down, you can change the colors. And sometimes changing colors will help see, okay, where is my enclosed region? All right, so I'm going to list out my order of pairs. My order of pairs are 1, 4, 1, 2. And you know what? I should leave some space to do a problem. So let me leave a little bit of space. 1, 2, 5, 2, and finally 5, 8. So those are my different vertices. And what I'm going to do, this guy is not part of the graphs that you use. So if you notice, the inequalities are what I graph over here. This function is what I'm going to substitute my ordered pairs into. So basically I'm going to find f of 1, 4. So instead of 3 times x and 2 times y, whoops, don't write y, I'm going to put in my x coordinates, so 3 times x, and then 3 times, or 2 times y. So I get 3 minus 8, which is negative 5. I'm going to do 3 times 1, 2 times 2, which is 3 minus 4, which is negative 1. Okay, then I'm going to do 3 times this x coordinate and minus 2 times this y coordinate. I get 15 minus 4, which is 15 minus 4 is 11. And then finally 3 times my x coordinate minus 2 times my y coordinate, and I get 15 minus 16, which is negative 1. All right, so here's all my different values. And now I'm going to pick my maximum and my minimum. 11 is my maximum. So if I was looking for the maximum, again, that would be finding like your maximum profit or whatever you're trying to maximize. And then this would be my minimum. Is that how you spell minimum? I don't think so. Minimum. Oh my Lanta. Okay. Minimum. There we go. So maximum value is 11. Minimum value is negative 5. So you graph the inequalities, find their vertices, and then substitute those vertices into your given function of x and y. Okay, so for this example, again, we graph the inequalities. So I have the inequalities there. There's 3 of them. There can be 3, there can be 4. I think on some of your classwork there's as many as 4. So I graph the inequalities, and then I find the enclosed region, which in this case is here. Again, you can change the colors to kind of help you out find that enclosed region. So the vertices of my enclosed region are negative 5, negative 2, 1, negative 2, and 3, 2. So that's what we're going to substitute into the function. Let's copy that graph over here. So 3, 2, negative 5, negative 2, and then 1, negative 2. All right. Oh, that is not a neat line. How in the heck? Sorry. Whoops. That is not what the line I meant to do. Hold on. There we go. There we go. There we go. And then as carefully as possible. There we go. So there's my enclosed region. All right. So now we're going to do the function. So 4 times x minus y. So in this case, it's going to be negative 5, negative 2. And I highly recommend whenever you substitute to put in parentheses. And you could type it in to Desmos just like you see there. So you could type that in. It'll give you your answer. In this case, it's negative 20 plus a negative 2, because minus a negative 2 would be the same as adding 2. So negative 20 plus 2 is negative 18. Here I'm going to do 4 times my x-coordinate is 1 minus the negative 2 again. Again, minus the negative 2 is the same as adding 2. So 4 plus 2 is 6. And then I'm going to do 4 times 3 plus 2. Nope, minus 2. I wrote that problem wrong. Okay, the function is 4 times x minus y, so 12 minus 2 is 10. So now we're going to find our maximum. There, it's 10, so that's our maximum value. And then our minimum value is negative 18. Graph your inequalities. Find the enclosed region, pick your vertices for that enclosed region, and substitute each one of those vertices into the given function. Then find which was your minimum value and your maximum value. One thing, let's say if more than one was 10, 10 is still the max. Or if more than one of these problems give me negative 18 is still the min. So no matter how many times it appears, it's still the max or the min. Okay, in this example, my inequalities are x plus y has to be bigger than negative 2, 4y is less than or equal to x plus 8, and then y has to be bigger than or equal to 2x minus 5. And when I graph those, here's my bounded region. All right, so let's see, my vertices are 0, 2, 4, 3. And then you can round the decimal. You can change it to a fraction if you want. I'm just going to round the decimal. All right. So let's see. We'll do 2.3, which would be 2 1/3, which is 2 1/3, which is 7/3. So I can use 7/3 there. And then negative 0.3, which is repeating, which is negative 1/3. So you can use those as well. All right. So let's see, 0, 2, 4, 3. 1, 2, 3. And then let's see, 2.3 negative 2.3 negative 1.3. It's going to estimate it's about right here. Do my solid line. Whoops, I missed. I'll just make that point bigger. All right, so there's my enclosed region. I'm going to substitute into my function, which is 4 times x plus 3 times y. So in our case, it's 0, 2. 0 plus 3 times 2 is 6. So 0 plus 6 is 6. Do 4 times 4 plus 3 times 3. So 4 plus 3, no, not 4 plus 3, 16 plus 9 is 25. And then I'm going to do 4 times 2.3 plus 3 times negative 0.3. And when I type that into Desmos, I got 8.3. All right? So my minimum is 6 and my maximum value is 25. So there's my minimum and maximum when it comes to this set of constraints and our system of inequalities, which we also call the constraints, and when I put it into the given function. I wanted to do a word problem, even though you don't have one in your classwork, just to for you to see who uses it. A backpack manufacturer produces an internal frame pack and an external frame pack. Let X represent the number of internal frame packs produced in 1 hour, and let Y represent the number of external frame packs produced 1 hour. The inequalities X plus 3Y is less than 18, 2X plus Y is less than or equal to 16, and then X is greater than or equal to 0 and Y is greater or equal to 0. Describe the constraints for manufacturing both backpacks. Now, if you look at the X is bigger than or equal to 0 and Y is bigger than or equal to 0, that's because you can have negative backpacks. So that's why they're saying, hey, it has to be positive. Those have to be positive. So that's one reason they have those constraints. Use the profit function, 50x plus 80y. So it might be like I make $50 per internal backpack and $80 per external frame backpack, and that's where that function comes from. And so given the constraints, what's the maximum profit for manufacturing both backpacks for the given constraints? All right, so I graphed that into Desmos. All right, I graphed it into Desmos, and then I found this is the area where they overlap. All right, so here are all my possible combinations of backpacks. So I could produce no backpacks. I could produce no, actually that's going to be 0, 0. So that's producing no internal, no external. 0, 6 would be no internal frames and 6 external frames per hour. 6, 4 would be 6 internal backpacks and 4 external per hour. And then finally 8, 0 would be producing 8 external and no internal. Nope, 8 internal, no external backpacks per hour. So our function is 50 times X plus 80 times Y. So 0, 0, I would make no money. All right, 50 times 0 plus 60, nope, 80 times 6. So 0 plus 80 times 6 is 480. So $480, that's how much I make that hour. 6, 4 would be 50 times 6 plus 80 times 4. So let's see, that's 50 times 6 is 300. Plus 80 times 4 would be 320. When I add those together, I would make $620 and per hour. And then finally 50 times 8 plus 80 times 0, that would be 400 plus 0, which is $400. So to maximize profits, I got to find the maximum value, which is $600. So the maximum profit is $620, and that's when I make 6 internal frames and 4 external frames. All of these points in here, so if I picked any point in this space here, all of those would be less than 620. So there's still possible combinations I can make, but they all be less than 620. So when we're dealing with linear programming, we're going to get a set of constraints or inequalities. We graph those, find the vertices of the enclosed region, and substitute those into function to pick a maximum and a minimum. So what you're going to do is finish those remaining questions on the next page. Let's see, that's numbers 1 through 3, and then 4 and 6. I cut out 5 because it didn't work. Okay,